Hello and welcome to Scaling Our Solar System. Hi, I'm Dave from Physics and Astronomy at Purdue, and I'm going to run through the materials that you'll need to do this lesson and give you some guidance in how to go about doing it. The basis of this lesson is to have your students create an accurate scale model of the solar system, accurate in both size of the planets and distance between them relative to the sun. Let's start where it all begins, the sun. Your student teams will blow up balloons to about 10 inches in diameter. Keep in mind, the larger the sun, the larger the planets, and more significantly, the greater the distance between them. So with a diameter of about 10 inches, the amount of space that you will need to step off the solar system will be something around 1,200 feet. So keep that in mind. Your students will measure the circumference of the sun and from that calculate its diameter. And from that diameter, using an online simulation, they will determine the relative size, the diameters, of the planets. From their calculated diameters, students will make scaled model planets of Play-Doh or other suitable material corresponding to the diameter of their sun. Here's an example of one student's scale model Play-Doh planets. It's a good visual for the relative size of the planets. Now the next step after creating these scale model Play-Doh planets would be to extend the model outside. Students can create a linear model of the orbits of the planets in the solar system. They can mark the orbit beginning with the sun. They can step off the distance from the sun to the first planet, Mercury, from Mercury to Venus, Venus to Earth, and so forth, and mark each planet with a stake and a photo. To mark the locations of the planets in their respective orbits, we use a variety of things. We sometimes use a garden stake. And to the end of a garden stake, we clip a little binder clip, and when the stake is hammered into the ground, they can attach a photo to identify the sequence of planets. And if we are providing materials for you to do this lesson, you will also receive pictures of the planets that you can cut apart and attach to the orbit markers that you put into the ground. We also have, if you don't want to take the sun outside, and that might be difficult, an image of the sun. So start with the sun. You can mark each of the 8 planets in sequence, and you'll have your scale model solar system. The other things that we will provide if you are using our materials will be extra balloons, Play-Doh to make the planets, and you'll also use a long measuring tape. Now the purpose of the measuring tape is not to measure the distances between the planets. It's to measure a fixed distance either in the hallway or on the sidewalk where students can pace off a number of steps and then determine the average distance in feet or meters. And when the students go outside to pace off the distance between the planets, every student can do that, and they can compare the number of paces and agree on the correct distance from one planet to the next. Okay, so before I leave you and we take a closer look at doing the lesson, I'll also point out that we are including an extra lesson called Eclipses. And it's a lesson based on also scaling the distance between the Earth, Sun, and the Moon. We're going to give you a couple things to get you started. The lesson will be self-explanatory. We have some 2-foot balloons, which take a long time to blow up, and some pearl head pins. Your eyeball is the Earth, the pinhead is the Moon, and the length of your arm is the approximate distance between them at that scale. How far back do you have to be from the sun in order to observe a total eclipse? Those distances can be measured and the proportions compared, and you have, again, a pretty good model of the Earth, Moon, and Sun distances and size relationships. So we're providing you a couple of basic things here to get you started, and you can have some fun with that lesson as well. Once we have our balloon, we've measured the circumference of the balloon and calculated the diameter, we're ready to go to the Exploratorium website, Build a Solar System. You can copy and paste the link from the written lesson, or just Google Exploratorium Solar System, and you will find it. So we see the opening page, build a solar system. Let's scroll down. To get started, all we have to do is put in the diameter of the sun. I measured mine in inches, and so I had a diameter of 10.2 inches, and I'll hit calculate. I see each of the 8 planets, including Pluto, and the planet body diameter. Now, since these are relatively small numbers, I'm going to use the millimeter diameters. Notice that the Earth is about 2 millimeters. That's pretty small. Earth, Mars, Venus are similar in size. Jupiter, Saturn are quite a jump up. From those diameters, our students will create Play-Doh models of each of the planets. Now, in addition to the planet body diameters, we also have the scaled orbit radius in feet. Now, it's feet and inches, but at this scale, I'm going to ignore the inches. I'm going to go by 35 feet, 66 feet, 91 feet, and so forth. Those are the distances of each of the planets from our scale model sun. Now, from a practical standpoint, while these numbers are accurate distances in our model from the sun to each of the planets, we really want to know the difference between the planets, because when we go outside to step off these distances, we don't want to start at the sun every time. We're going to step off the distance from Mercury, and then from Mercury to Venus, Venus to Earth, and so forth. So in our calculations, we will actually subtract these to get the number of steps from one planet to the next. While these distances are in feet, we're going to have students convert them from feet to number of steps, and we'll show you how to do that. So students will not measure these distances, they will pace them off in a normal walking pace, or they will step them off in a normal walking pace. Okay, let's look at some photos of this lesson in action. The first thing, students will blow up a balloon and determine its diameter. This isn't probably the best way to do that. I would leave the string on the balloon until it's marked, then take it off and use something longer than a 1-foot ruler, but that's what we did at the time. Then, using the balloon model sun, students put the diameter into the website and create their Play-Doh planets. Some students get a little more carried away and get into the detail. I will warn you, students can spend way too much time on this, so you've got to prod them along. Then we go to the hallway or outside and determine how many paces, how many steps are in a given distance. We typically use 50 feet. Students will step off 50 feet, determine how many feet per step, and that's what they will use when they go outside. Then we head outside with our planet stands, stakes, and step off our model solar system. We have gone, I hesitate to say, a quarter of a mile, 1,200 feet, and have gotten just to Saturn. Try this yourself. I've done it many times, and each time I do it, I learn something new, and I am totally amazed every time at the insignificance of Earth and humans and the significance of the scale of our solar system.